Hello everyone, this video is about differentiation past paper questions. Maybe read the question first. Part I. Express the length of PQ in terms of T, simplifying your answer. So the length PQ, we have to find the length of PQ is so when the time is t, the y equals 5x and x coordinate of p is t. So the p here is when the time is t. The q is also when the time is t or when the x is t. So we simply replace the x with t. The q is the higher value here, so the q would be using the curve. We replace the x with t. We get the y value of q, t times 9 minus t squared, minus when the for the straight line, when the time is t, the y is 5t. So this minus this simplify, we get this thing in terms of t. Now we're finding the maximum value of the PQ. So to find maximum value, we use y prime equals 0. So let's just call it L for the length. L equals this. The maximum is when L prime equals 0, or dl dt, or the derivative, which is 4 minus 3t squared equals 0, which means the t can be plus minus the square root of 4 over 3. And we cannot use negative for time here, so we use the positive value of t, because obviously this is also when it's positive. So we use the positive t, which is 2 over the square root of 3. The maximum L is therefore when the time is 2 over root 3. So you just plug in 2 over root 3, 2 over root 3, use a calculator, you get this is as the final answer. Next question. Read the question first. Find the normal through A. So to find the tangent gradient, we can differentiate first. So if we differentiate, plug in 1, we get minus 1/2 4x minus 3 chain rule times 4. Okay, this is the chain rule times 4 chain rule, and the new power is minus 2, of course. We plug in 1, so we get minus 2. This is the tangent gradient. The normal gradient is minus 1 over this, basically, so 1/2. So the normal equation is y minus y1. So the point is 1, 1/2. The y1 is 1/2, the x1 is 1, the m is 1/2. So we get y equals 1/2 x only for the normal equation. Find the x coordinate of the point where this normal meets the curve again. So we need to find the point of intersection between this normal and the curve. So 1/2 x equals this, which is 1/2 for x to the minus 3 to the power of minus 1. We can cancel out 1/2. So to the power of minus 1 means 1 over. We get a quadratic. We solve the quadratic, we get 1 and minus 1/4. Of course, we don't use 1 because 1 would be the original point A here. So we need the other point, so we need the x equals minus 1/4. Now, this is about related rates. A point is moving along a curve in such a way that it passes through A. Its x coordinate is decreasing, so dx dt is 0.3. Decreasing means negative, so actually negative 0.3. dx dt is negative 0.3, and we need to find dy dt when the x is 1, because at A that means when the x is 1 and when the y is 1/2. So we know the y and we know the y prime. We can use dy dt equals dy dx dx dt. The y prime or dy dx is this guy here, which is minus 1/2 times 4 is minus 2. So minus 2 times 4x minus 3 all to the power of minus 2. The dx dt is minus 0.3. We plug in x equals 1, of course, and we get the final answer. Next, we have the tangent parallel to the line. So parallel, since it's parallel to this line, this means the gradient must be the same as this gradient, which is minus 3. So the f prime is minus 3. And this is f. The f prime we differentiate 3x squared and so on. Minus 3, solve the quadratic, we get x equals 3. And when the x is 3, the y is, we use the original, y equals 6. To find the equation, we need y minus y1 equals mx minus x1. The x1, the y1, the m is minus 3. So we get the equation. And now the function f is this. Increasing means the gradient is positive. The f prime is positive. The f prime is again this guy. It's positive. We solve the quadratic, find the critical points, number line, check using some random values in each interval. We get plus minus plus. We're looking for positive, so smaller than 2 or bigger than 4. But this is for x is bigger than k. So this means the smallest value of k is therefore 4. That's the final answer. So it's increasing when the x is bigger than 4. The smallest value of k is 4 then. Next, we have y original function. Dx dt increasing 0.02. So dx dt positive 0.02. We are looking for dy dt when the x is 1. So if this is y, the dy dx is, we differentiate. Dy dt is dy dx, dx dt. Dy dx is this guy here, dx dt is 0.02. We plug in x equals 1, use a calculator, you get the final answer. Right, you can read the rest on your own. I'll see you again next time.